Welcome back, Akira Bike Project fans. I left off the last video fabricating the exhaust system, a nice symmetrical setup that swoops down and back from the heads of the transverse V-twin CX500 motor. In this video, I'll design and fabricate a new cooling system that integrates a split radiator design. The CX500 was the first production liquid-cooled motorcycle. And like most liquid-cooled bikes since, the radiator sits behind the front wheel under the steering column, directly in the wind shadow of the front wheel. The coolant flow starts by circulating around the engine through the thermostat and back into the coolant pump in a small return line. But once the engine is warmed up, the thermostat opens and sends the majority of the coolant through the radiator and then back into the coolant pump. With my rear engine recumbent, the motor is right behind the seat, where there isn't much room for a radiator. The front wheel is a couple feet away as well, and there isn't much room there for a wide radiator with the footrest and other frame components. So I decided on this split radiator system, where half the radiator sits on either side of the seat. It's tilted a bit forward to reduce the cross-sectional area. It's low enough to not get in the way of getting on and off the bike, and high enough to not impact the max lean angle. So in this setup, the coolant leaves the thermostat once the engine is warmed up and goes into an expansion fill tank, which is the high point of the system. It then flows into the top of the right radiator, out of the bottom of that radiator and into the top of the left radiator, and then out of the bottom radiator and returns to the motor. There's also an overflow tank tucked under the seat with a visible sight glass, which probably isn't really necessary, but I think looks cool. Each radiator will get fans to help airflow when it's idling in traffic, and ducts as well to help optimize the airflow when traveling at speed. If it's necessary, I can also add an auxiliary coolant pump in between the radiators, as there's plenty of room down low. Okay, let's build it. I want to mount these radiators onto the side of the bike here, and these bars are in the way, and these bars are doing nothing but holding these frame pieces in place. So the next thing I'm going to need to do is just fabricate some posts that will go inside here and hold both of these up, and then I can start working on the mounting brackets for these radiator cores. I made these frame jig posts the same way as all the others, cutting a 2" by 2" square tube to length, grinding the ends, sanding down the mill scale, drilling out the base, making some frame holders from angle iron, and setting it all up on the frame jig table, using the frame to help align everything, and being meticulous about making sure everything is precisely aligned before tack welding it, taking it back off the table, and doing a final weld, and then painting, and then reinstalling it. Before I could start making and modifying these radiator components, the first thing I'd have to do was learn how to TIG weld aluminum. So I started out by practicing on a bunch of these aluminum welding coupons. Next I did some outside edge welds on 1" flat bar stock. I found these to be the easiest welds to do. I then combined these L bars to make small containers, doing more edge welds and now outer corner welds. I figured I could attach an airline quick connect to these containers, and then do a quick pressurized leak test on them to see how good my welding was. It ended up having one small pinhole leak in one corner, not bad for my very first attempt at a container. A subsequent quick weld in that spot sealed it right up. I welded up a bunch more containers, but using 1/4" NPT bungs to screw in the air connects with, and then leak tested and repaired each of those. With that, I was confident enough to go ahead and make the first custom part, the expansion fill tank. I designed this in SolidWorks and had it laser cut by Send Cut Send, and I designed it with tabs and notches to help hold it together without a fixture, and that seemed to work great. I started out by welding the 1/4" NPT bung on the back plate, but this is only for leak testing and will be plugged up while in use. Then I added numerous tack welds, small single dot welds, in different places to hold the container in shape. With the tack welds added, I could go ahead and start welding the edges. I frequently moved the weld around to keep any one area from overheating, and welded some of the longer seams in multiple segments. I used the compressed air gun to help cool the parts between welds, and the steel also helped absorb excess heat and keep the part from moving around while I was welding. I was pretty happy with the results, so next I would need to move on to welding in the coolant pipes. These are very narrow wall pipes, so I took some time doing some practice welds on these too. The pipes would need raised rings, so I put them in a bead roller, which was actually slightly too large for the pipes. Some grinding on the roller resolved that problem. And that worked after a few tries, so with that I cut some pipe sections, rolled beads on them, and delicately welded them into the tank. With the pipes and the edges all done, I could now move on to the fill cap. It definitely didn't all go smoothly though. I gotta wait for everything to cool, and I gotta clean my electrode. Okay, I have here the expansion fill tank, and I finally welded the pipes onto it. That was tough. I have a newfound appreciation for guys who do this kind of stuff, who make radiators from scratch. But I think it's okay. So I'm gonna leak test it. I have a 1/4 NPT port here with a quick air connect, and so I'm gonna let a little air in there and see if it bubbles out. So yeah, let's plug it up and leak test it. Amazingly, literally the only place leaking is that vent cap. I thought that that is not going to leak because the pressure cap will hold that closed. But maybe the compressed air is enough to open that, even though I'm only letting a little bit in. But that tank is not leaking anywhere else. That's crazy. Oh, it is leaking near that port. There's a little divot under that port. That seems to be the only spot. Yeah, man, that's not leaking anywhere else. One leak. That is pretty impressive. A quick touch up under that cap and it was all set. I think that definitely came out pretty good for my first try, and it was definitely good enough to move on. The tank would need some mounting brackets. I fabricated those real quick out of aluminum C-channel and welded one side onto the tank. The tank gets mounted on this frame bar slanting up behind the seat. The coolant flow from the thermostat takes a U-turn in this short red hose here, which has a narrow gauge loose wound spring inside of it to keep the hose from kinking. Some custom made hoses would be ideal here, but for the sake of this prototype this should suffice just fine. With the tank now made, I realized a new problem when I tried to mount it. There wasn't enough room for the thermostat. The coolant flows out of the heads through these elbows and proceeds in straight pipes to the thermostat housing. Unfortunately, that causes it to interfere with the expansion fill tank I just made, especially with that 1/4 inch testing bung on the back of it. First I tried giving the pipes a small S-bend by cutting the existing pipes and using them as end mounts, and then bridging them with a flexible coolant hose. Okay, I tried to do this with hoses, and you can see they just are too crimped. There's no way that fluid is flowing through there decently. You can put springs inside of these. That didn't help. You can put springs outside. I can't find springs with the right size. I next tried a tight loop held in shape with an internal spring, which looked quite good, but puts a lot of stress on the ends of the thermostat pipes, which are just held in place with O-rings and friction, and also ends up blocking the thermostat outlet hose which goes into the expansion fill tank. I remembered then that the early liquid-cooled aircraft were just copper jackets brazed over the cooling fins of air-cooled engines, and thought copper plumbing pipes might work well, and they sure did. They met the requirements of the tight S-curve and were rigid so they didn't want to pop out either, and they fit perfectly over the aluminum end pipes. I was going to need to braze aluminum to copper, but HVAC guys do that all the time with this Alcop stuff, and I would need to worry about an electrochemical effect over the long run, but this should be good enough for the prototype until I can get custom all aluminum pipes made. I ordered some of that and indeed brazed the aluminum ends to the copper plumbing pipes, and it seemed to work pretty good. Thanks for watching. This is it for part 1 of the cooling system, but part 2 is already done and uploaded and will be released a week from this video. But it's available now as an early release to my patrons. If you're enjoying this project, please consider becoming a patron to help accelerate the build. This will not just be a one-off build, as I'm making jigs, fixtures, and molds along the way. I'll be producing these and will support multiple engine platforms and offer either complete builds or kits. So please support this, one of the most interesting things going on in motorcycling today.